Thankfully, the clouds stayed away and there was a total solar eclipse.
Oh, don't stare at it. Have a cardboard box or something.
From interrupting radio frequencies to giving unclear information relays from satellites, this is what happened 10 minutes ago after the biggest solar flare in 17 years hit the Earth. Did you know that the Sun recently unleashed one of the largest recorded solar flares and that it had surprising effects on our planet and beyond? Well, on Thursday, December 14, 2023, a significant event unfolded in the solar system. This event called for celebration as millions of people experienced the magnificence of the skies above. Before exploring the amazing phenomenon, it is important to understand what a solar flare is and how it impacts the solar system. The Sun is the most important star in the solar system as it emits light and heat energy, which enables various life processes to occur. These include plant growth, solar energy harvesting, and light transfer. However, the heat emitted from the Sun is intense and very radioactive, making it harmful to Earth.
And so if one magnetic field with stored energy sees another magnetic field, those two look at each other and say, hey, if we connect, we can get rid of a lot of energy.
Fortunately, Earth has a mechanism that prevents harmful radiation from reaching its surface. However, what has happened has left the scientific community with so many questions and fears regarding the Sun and its energy. The Sun emitted an immense solar flare, characterized as an X2.8, marking one of the most powerful solar flares since 2006. Solar flares are sudden releases of intense radiation and energy, visible as bright flashes on the Sun's surface. The Sun's core is where nuclear fusion happens, so that the reaction can sustain the Sun's heat and luminous characteristics. Sometimes the energy on the Sun's surface is too much, and it is released like a wave, and this is called a solar flare. Thanks to the advancements made in the scientific world, it is so much easier to detect changes in the Sun's intensity, and it allows the detection of several things to be possible. However, what the team at NASA discovered this time made them rethink all their decisions and plans regarding safety and how they understand the Sun.
And this can be equivalent to millions of nuclear weapons exploding simultaneously.
The Sun is vital as it helps sustain life on Earth. Advanced instruments and satellites, including NASA's Solar Dynamics Observatory, allowed us to observe and measure this solar flare's magnitude. The intensity of the solar flare helps determine the activities taking place on the Sun, making it easier to predict future patterns. Data recording on the Sun has been carried out for decades, and it serves as a great reference point, helping predict weather patterns, amongst other things. The imagery captured by the advanced instruments and satellites showcase the Sun's surface, erupting with a massive plume of plasma, also known as a coronal mass ejection, CME. This ejected plasma, traveling at speeds of millions of kilometers per hour, is a distinct yet interconnected phenomenon with solar flares. While the solar flare itself is generally harmless due to the Earth's protective atmosphere, the following coronal mass ejection can interact with our planet's magnetic field, triggering geomagnetic storms. These storms, in turn, can impact power grids, satellites, and radio communications. On the mentioned Thursday, about 17 hours after the flare, the coronal mass ejection reached Earth, inducing a potent geomagnetic storm that persisted for several hours.
But with gravity crushing things down, things get close enough together and nuclear fusion happens.
Despite its disruptive nature, the geomagnetic storm had a visually spectacular outcome. It gave rise to breathtaking auroras, or northern and southern lights, visible in various parts of the world, including uncommon locations like Hawaii and Cuba. Auroras result from charged particles from the coronal mass ejection colliding with Earth's upper atmosphere, creating vivid displays of colorful lights in the night sky. Numerous individuals captured and shared awe-inspiring photos and videos of these auroras on social media, marveling at the wonders of this natural phenomenon. Now, you might be curious as to why this solar flare stands out as unusual and significant. There are several reasons for this distinction. Firstly, it ranks among the largest ever recorded solar flares and holds the record as the most substantial one within the current solar cycle, an 11-year cycle representing the Sun's activity.
Here's nature giving us an example of how these phenomena work, and so it gives us an opportunity to study that, to hone our physical theories, our calculational tools. And so by looking, for example, at the effects that we see on the Earth.
The Sun's activity undergoes fluctuations, transitioning from periods of low activity, known as a solar minimum, to high activity, known as solar maximum. Solar maximum is characterized by increased sunspots, dark patches on the Sun's surface, indicating heightened magnetic activity. More sunspots typically correlate with a higher likelihood of solar flares and coronal mass ejections. However, the ongoing solar cycle that commenced in 2019 has been remarkably decreased, featuring minimal sunspots and flares. Some scientists even projected it to be the weakest cycle in the last 2 centuries, anticipating a lack of major solar flares until 2024.
We were able to figure out that if we use carbon, that we can trace the origins of the solar wind with a higher accuracy, so we can figure out where it's originating on the sun.
When the solar maximum is expected to peak. Therefore, the occurrence of this massive solar flare during a period of low solar activity was both surprising and unexpected. This solar flare made the scientific community question their understanding of the solar system and what other surprises the Earth is in for. Science is based on facts, and these facts help determine several things, including how various natural phenomena affect the Earth's atmosphere. The sun is one of the few things in the solar system that scientists are proud to study and understand. Based on facts and evidence, the scientific community has made strange discoveries, all of which have aided in making life on Earth easier.
He brought to us this, this idea of sonifying data, which is really, quite innovative. And maybe even transformative.
Unfortunately, not all discoveries have been celebrated with champagne, as some of them call for a major re-examination of all facts on Earth. This specific solar flare challenges our current understanding of the sun and its behavior, leading to questions about the accuracy of our predictions and the adequacy of our preparations for future solar flares and coronal mass ejections. It emphasizes the need to re-evaluate and enhance our understanding to better anticipate and lessen the impact of such solar events. To make it clearer, the solar flares should not impact the Earth in a massive way.
The specific nuclear reaction that powers the sun is fusion. Fusion of hydrogen into helium. You take 2 hydrogen atoms, you ram them together, and what's left over is a helium atom.
However, in cases like these ones, the flares can disrupt several things. Remember, the flare is a surge of energy that interacts with the Earth's atmosphere, creating a geomagnetic force that is seen as the northern and southern lights. In most cases, the flares are not harmful. However, the scientific community has taken pride in knowing that it can predict when the next flare will happen and detect it early enough. In this case, it wasn't expected to be such a huge solar flare, as the sun is in its minimum period. Such a surprising thing makes the scientists question their understanding of the sun. There are several worrying questions that threaten everything the world knows about the sun. If such a solar flare can happen so unpredictably, is Earth well equipped for a larger solar flare? Is what we know about the sun sufficient, or are we just learning the basics? Indeed, the solar flare on Thursday presented both risks and benefits, as reported by Earth.com. Power grid fluctuations were likely affected, and spacecraft in low Earth orbit could have experienced irregularities and communication issues. The full extent of blackout impacts remains unclear.
Was something that was periodically happening every roughly 27 days, and that's exactly the rotational period of the sun.
The Earth is one big communication dish, relying on satellites to get information about everything. If a solar flare interrupts the satellite's waves, communication becomes hindered, and there are serious chances of having some parts of the world cut off. Similarly, the world is so dependent on power that a little bit of fluctuation can affect continents, leading to serious hazards. Such things are what the scientific community has tried to avoid by studying the sun intently and recognizing the times when a solar flare is released, which is crucial. So when such a surprising flare is released, the team is worried that maybe they don't have the sun figured out just yet. This makes the team reconsider all their plans for protection. The Earth's atmosphere protects the surface, but what if the sun's activity is increasing? While it is interesting to document the largest solar flare yet, it is also worrying to think about the implications. On the positive side, solar flares have the ability to create spectacular auroras.
It's actually hard to get 2 atoms to fuse. 2 protons have the same charge, they're both positively charged, they want to repel each other.
These not only offer a beautiful visual display, but also provide valuable information about Earth's magnetic field and atmosphere. Studying auroras helps us understand how the magnetic field protects us from solar wind and coronal mass ejections, and how it changes over time and space. Such information makes it easier to study various phenomena and understand their implications on the Earth and the effects they cast upon life on Earth. Additionally, it aids in researching the chemistry and dynamics of Earth's upper atmosphere and its response to solar activity and climate change. Auroras, inspiring wonder and appreciation for the beauty and mystery of the natural world, serve as a source of inspiration for many. Take a minute to admire these beautiful auroras recorded over the years. Seeing one makes you appreciate the beauty the world has to offer. It gives you a feeling of peace and serenity as you realize that there are forces operating beyond what humans can control. This is an exciting yet scary thought. The rare and remarkable event on Thursday highlighted the power and beauty of the sun.
How about we try an emotional journey? So, week later, I came back and I'd created this iteration whereby you take a journey from the Earth out to the sun and back with sonification audio kind of underlying this whole entire experience.
While underscoring the challenges and opportunities of living in a solar system, the occurrence raises important questions about our preparedness for more powerful solar flares in the future, which could cause severe disruptions and damage to technology and infrastructure. Addressing such challenges requires consideration of how to mitigate risks and enhance the benefits of solar flares for society and civilization. It prompts exploration into what we can learn from studying the sun and its activity, and how that knowledge can improve our understanding and exploration of the solar system and beyond. Man's curiosity has taken him to space beyond the Earth. It has allowed him to learn that there is more to our world than blue skies and cloudless nights. These discoveries have made it easier for man to come up with facts, supporting various theories and giving a firm ground to science over belief. All these successes make it possible for current humans to predict various natural phenomena and prepare adequately for when disaster strikes. Gone are the days when we used locusts and birds to tell whether a flood was coming.
Protons don't like to get close together. They have to come together with a huge amount of energy or velocity to get close enough to begin to fuse, and that's very, very rare.
Today, so much is possible thanks to the advancements made in the technological and scientific worlds. As we applaud the team behind such interesting scientific facts, we don't forget that a bigger question lies ahead. If a larger solar flare is emitted by the sun, how prepared are we to ensure that our lives aren't interrupted in disastrous magnitudes? As the sun continues its life cycle as a middle-aged star, approximately 4.6 billion years old, ongoing scientific studies deepen our understanding of its complex processes, contributing to insights into astrophysics, space weather, and the broader cosmic context in which our solar system exists. In conclusion, as we continue to observe and learn from the sun, it becomes clear that it is not only our source of light and heat, but also our window to the universe and a guide to the future. Understanding and answering these questions will be crucial as we navigate the complexities of our solar system. Solar flares have been emitted, but the difference in this one is that it was least expected, and it is recorded as the biggest one yet. In the current solar cycle, scientists noticed that it had been unusually quiet, so maybe this was something to remind the Earth that the sun was still shining and all activities were still going on.